Friends, there is so much political activity going on right now, and we are bombarded with so much politics, so much so that we are missing out a larger picture. And the larger picture is related to what mankind is doing with the research and development in the space exploration. And the latest one is we have seen two big setbacks. And most of us may not be even aware. There was a setback. There was a private company. They were sending their probe in the outer space, and after 300,000 kilometers, they lost contact with the probe. So this was one setback. The second one happened today, where the SpaceX, SpaceX launch, exploratory launch, failed after the second stage. So there are two consecutive failures in space exploration, and therefore it is very evident that sending the space probe from Earth is rather expensive and also very tedious. Lot of efforts are getting wasted in liftoffs and safe return. So the theory is that if we want to make it big, if we want to make it realistic, we must shift our construction to this space where there is no hindrance of extra liftoff, extra power is required, and which is prone to a lot of malfunction and accidents. So lot of efforts are going into that arena. The leader in that space is DARPA. DARPA is the Defense Research Organization of the US, and they are actually involving a lot of private parties to help them develop the construction in outer space, primarily using AI and 3D printers. So imagine a situation where there is a manufacturing complex out there in the orbit of the around the Earth, in a lower Earth orbit, or an optimum height from Earth, and construction of these spaceships are happening in a large scale. And if you are constructing in outer space using 3D printer, there is no problem with how much large the spaceship you can manufacture in outer space. That is a limitation when you're sending a probe from the Earth, because there is always a huge power required to beat the gravity of Earth. So therefore there is a lot of practical solutions available, and DARPA is actually doing a lot of this research in this area. So considering this, there is a lot of these development happening in DARPA with 3D printing technologies. And what they want to basically emphasize on this is that there is going to be significant reduction in the cost itself. The cost will be minuscule of what we are spending today in sending the rockets and heavy payloads into the outer space. The cost will reduce drastically. There could be initial cost, but then construction of larger spaceship, much more spacious, with all the tech which is built in into the future spaceship, and especially when we are sending future spaceships with humans in it for mining expedition and also exploration on Mars and outer solar system, we would need larger spaceship which will have facility for recreation, facility for exploration, scientific experiment, for growing food in farms, etc. So not like the today's spaceship where the space is quite cramped. We would need larger spaceship, and it is logical to construct larger spaceships out there in the orbit rather than constructed them on Earth and sending them to the space. This is a non-starter. So it's practical and also reduction in cost, because you will not be spending heavy fuel of liftoff. As you know, friends, some of you may be knowing that almost 80% of the weight of a spaceship is the fuel itself. So we can avoid all that cost, and maintaining, producing that fuel like liquid oxygen, hydrogen, etc. is rather expensive. And then most of it is actually used to lift off its own weight. And therefore is practical reduction in cost. Second advantage is increasing in efficiency. Increase in efficiency because you can get the raw material not from Earth. You can actually get the raw material from moon itself. You can actually start mining the moon. Getting the raw material from the moon is a lot easier than sending from the Earth, simply because moon is 25% in size as compared to Earth, and henceforth the gravity is 1/6. So making the liftoff of a rocket with raw material in it from moon is rather easier than sending raw material from Earth to the space. So you can use moon as a mining place, get the raw material. We know that there is a lot of titanium, there's a lot of gold on moon, there is a lot of helium on moon, there are a lot of other rare earth elements which are available on moon. Enough study is being done. Some is made public, some is still in the realm of top secret, but then nevertheless a lot of studies have been done for almost 100 years, and we know there are a lot of resources available on the moon which can be mined and shipped to a location where the construction facility can be stationed, and we don't need a lot of manpower because we can use 3D printers. Those 3D printers can be AI controlled, and the AI of controlling those 3D printers can be put on Earth, which is managed by humans. All right. Number 3 advantage of having this kind of facility is the sustainability. Sustainability is very important because if you are doing some sort of construction which is not really controlled, then it can emerge into a situation where there is a lot of space debris. So we do not want that, and therefore we can actually control the environment. We can actually mine whatever we need from various asteroids and moon, and therefore the situation will become much more conducive for sustainable development of space exploration. So lot of advantages that we see in building spaceships in this space. And the last one is expansion. So it is a lot easier to expand the facility, and then we can send humans for a month to just to monitor, and then they can work in shifts on rotation basis. So expansion is very much possible. The expansion can also be done by the robots. They can start expanding the construction facility out there in space. It is a lot easier. 3D printer is already on board. They can actually use 3D printer not only to construct the space probe parts, but also to expand their own space station. Now let's talk about the stumbling blocks that we may have. Not many, but there are still, nonetheless, there are few. One is the technical hurdles. So although on paper it looks like the technology is available, but then somebody has to piece together everything and make this plan a workable plan, which DARPA is already doing through its partner and its own funding from the government. But I think the technology solution needs to be provided in this space, and initial few launches cost will be slightly high, but once the system gets into action, then the technology challenges may be overcome over time. Safety is another one. As I mentioned, that we have to ensure that the system is absolutely foolproof. Otherwise, there is a chance of creating space debris. So we have to be very conscious and very, very particular about not having any waste out there in the outer space. So we have to ensure that there are no safety hazard for the planet, for the nature, and for the open space. And as you know, if something leaks in this space, it's very difficult to retrieve it. So we have to be very, very careful. In fact, the technology is right there available right now. It has to be very well controlled. And the last thing is the international collaboration. No one country will be able to manage this whole development on its own. We know DARPA is doing a lot of investment, initial planning, etc. And this is only the research phase right now. But in order to make this much more practical, we need international collaboration, so that a lot of these top countries can come together, pool their resources, create a partnership between the space agencies, so that different components can be brought in by different countries, and this whole process can become very practical. So friends, this is something which is latest in the space exploration. Like to know your comments, your thoughts. If you have any questions, don't shy. Feel free to send across your questions and comments. And thanks for joining me live. Thanks for watching. I will catch you again in the next one.